Okay, good morning, everyone. So we didn't have class on Tuesday. I hope everyone had a chance to watch that recorded lecture. As I mentioned in our previous in-person class, and I think again also during the recorded lecture, what I wanted you to do was work through the in-class exercise that day and then bring it to class with you, your name on the paper and sort of having filled out some of the things that you worked on. So if you have that, please pass it to the end of the row so I can collect those. While you're doing that, let's go over a couple of additional announcements here. Homework number 10 is due tomorrow by 5 o'clock. That'll be the last of these assignments that we briefly extend the submission deadline for. And, all right, are there any more? All right, so homework 10 tomorrow by 5. Homework 11 is due on Thursday, which is the same day that we're having our second midterm exam. Like the first midterm exam, the second exam is going to have two parts. Some conceptual questions that you're going to have to solve just with your own understanding. You can't use any sort of a reference. You cannot use the equation sheet. So some concept questions, and then part 2 is problem solving, which may include questions where you're required to use Excel. And so please bring your computer on the day of the exam. And for the Excel questions, you have to start with a blank workbook. And so if you'd like to outline the solution strategy on the page of notes that you're allowed to bring, then that's fine. You know, if you want to maybe list what the column headers should be, or an outline of the solution strategy, that's probably a good use of this one page of notes that you're allowed to use for part 2. I'll provide the equations that are related to time value of money and any sort of interest rate factor tables that you'd need for the exam. So any questions about the announcements or about the test? Okay. Well, we're going to be covering two different ideas today during our class. We're going to be talking about cost effectiveness analysis and replacement and retention decisions. And what that means is how long to keep equipment before replacing it. And both of these are used for situations that aren't necessarily just about picking alternatives that maximize the greatest profit. These are different types of questions, and we'll talk about them each individually. Now, cost effectiveness analysis, remember that there are a lot of situations where in public works or in private, in government sector projects where there aren't profit incentives, but the services have to be provided. There may be some other way that they are contributing to society that justifies doing the project without generating profit. And so some of those intangibles that we're talking about may be health care or accounting, police protection, safety. And so, for instance, in the case of law enforcement, having police on the streets isn't generating revenue necessarily. It's a very costly thing to have the payroll, the vehicles, the training that they require, but we all recognize that having laws enforced is a societal good, and so we're willing to pay for the expense. But still, there has to be some way of assessing whether each of these organizations is being cost effective. And so sometimes the benefits of these things are difficult to estimate in a dollar value. We already talked about benefit cost analysis, and that's a pretty useful tool for deciding whether projects are acceptable or not acceptable if the benefits of a project can be somehow translated into money. If you're able to assign a dollar value for a reduction in delay in the case of traffic, then you can calculate benefit cost. In the case of flood protection, if you can translate reduction in severity and frequency of floods into some sort of a dollar value of the property that's been protected, then benefit cost is a good way to analyze flood protection projects. But it's sometimes more challenging to apply benefit cost to these sorts of scenarios. And so traffic cameras. What's the dollar value of assigning traffic cameras where they're maybe catching speeders and taking pictures of accidents? Maybe you could get there with a really long, complicated study, but there are other ways of analyzing whether things are cost effective without having to jump through all of those hoops. There are benefits of traffic cameras if we think about accidents that have been averted, deaths prevented, people not running through red lights. That's a real thing here in Huntington. People love to run red lights. More than any other city I've ever lived in. There's lots of running the red lights here. So there's benefits, but sometimes these service sector projects are difficult to quantify in terms of the dollar value. And so what we do instead is we measure some other way of quantifying the effectiveness. And so the costs are easy to calculate. Those are the dollars required to buy the thing. Those are the budgets being requested by the entity that operates these service sector projects. But we use something other than dollars as the measure of how effective an agency is being. And we have an in-class exercise that illustrates that today. So let's take a look at just an illustration before we get into the in-class exercise. What if there were 4 different offices that processed passport applications? If any of you have a passport, you have to mail it off to some distant city, like I think New Orleans is where I sent my passport application most recently. They've got them all over the country, and presumably there are different costs for the passport office in New Orleans than compared to the passport office in San Francisco. Differences in rents, differences in the salaries that they have to pay people. There are regional variations in utility costs and so on. And so what if we wanted to find out which of these different offices is most efficient at doing the work that they have? And so this first data table, what it's showing is the 4 different offices, and then they have different operation costs per hour. And so what you can see here is that Office B, for whatever reason, they have very low operation costs. It could be that in this area the rents are low, or that they don't have to pay very high salaries. You look at Office C, the operation costs are very high. Maybe that's in New York City or something where rents are expensive and so is salaries. And then the other thing that we need to know in order to be able to do a cost effectiveness analysis is how much work they're accomplishing. And so we've got costs and some measure of work. In the case of an office that's processing applications, the way of measuring their work is just how many applications per month get processed. Now, there are other ways to look at it. This is ignoring, for example, like what if they're making mistakes? One of these offices may have a lot of different mistakes that they're making. Some of them maybe are doing it more correctly. And so we could, if we thought about it a little bit further, we could probably tweak this measure of effectiveness even further to say number of successful applications or number of applications minus errors or something like that. But just for sake of illustration, we'll keep it simple. We've got our costs and our effectiveness. And both of them are per unit time, but even though we're making a ratio, the time doesn't have to necessarily be the same. We could convert these costs per hour into cost per month by multiplying by 40 hours per week and 4 weeks per month. But since we're comparing the ratio A versus B versus C versus D, we don't necessarily have to have the same time units in the numerator and the denominator. So here in the cost effectiveness ratio, what you can see is all we've done is we've got the costs, $875 per hour, and then applications per month, so we had C divided by E. And so the units of this would be dollars per hour divided by applications per month. And so, if you want this cost effectiveness ratio to mean something that's more understandable and more tangible, you may need to reconcile the time units. But if all you want to do is compare these 4 different offices, you can leave it as is. And so let me ask you this. Which office is most efficient at processing applications in terms of work accomplished per budget? Which office is is the best one there? And why do you say B is the best? Right. So what we want to do is we want to minimize the cost per effectiveness. So you want a small c and a big E. You want them to spend as little money as possible and do as much work as possible. So we want this ratio to be as low as we can. So the question was, we've got a budget of up to $1,600 per hour. So which of these offices are we going to send money to if we can choose? Like, we don't necessarily have to fully fund all of them. You want to prioritize your spending so that you are able to maximize the number of applications that are processed. And so what you should do is you should, first of all, fund Office B, because they're the most efficient. And so this $1,600 per hour, Office B is going to take $450, and then they're fully staffed up and they're operational. Now, who's your second choice? Once you've funded B, who gets money next? A gets money next because they're the second most efficient office. And so what we're doing is we're going through and we're giving money in order of who's most efficient, and then the least efficient people, if there's any money left over at the end, then we'll give some to them. Sometimes in situations like this, you can partially fund an office. And the problem statement will tell you, either the organization has to be fully funded, or sometimes they can be partially funded, like if you get to the end and there's just part of the money left over. So you'll notice what I'm doing is I'm rearranging from this step to the next one. So now they're sorted. This was the original data, and I sorted it from most efficient on top and least efficient on the bottom. And this fifth column of cumulative cost says if we just fund Office B, it's $450. If we have Office A and B, then it's $1,325, because that's the $450 for Office B and the $875 for Office A. So at this point, our total number of applications that we're processing is going to be the 8,900 plus 1,400 on the second row. Now the third row is showing that we are 2,425 if we want to fully fund Office C, but we can't do that because our budget limit is $1,600 per hour. So if each of these offices has to be fully funded in order to open at all, then we should only go with offices B and A. And then we wouldn't be able to spend the rest of the money. So does that make sense to everybody, what we've done to prioritize our spending? I mean, it makes obvious sense. You fund the people who are being most efficient first, and then the people who are least efficient, they get paid last, or they're your lowest priority for spending, I guess is maybe the more accurate way of saying it. They may not get money at all. This is called capital rationing. And so that's a phrase you need to understand. What it means is if there's a budget limit, then rationing is the process of deciding who gets how much. And so like during wartime, food is rationed, and they give higher priority to soldiers for receiving food because they're involved in the actual defense than maybe conscientious objectors. So rationing, the idea there is that you have to give the most resources to the people who are having the greatest effect for whatever cause you're trying to focus on. And in this case, it was processing passport applications. Okay, so here's your in-class exercise. What we're going to be doing is looking at a couple of NGOs who exist to prevent poaching. And we want to find out if you're managing money for people who want to have the biggest bang for their buck, which organizations should be funded? Why didn't I get these before? What's the story with this? Oh. Okay, so on this one, if you want to set it up in Excel, you can. You can also do this front page just by hand. This isn't anything that's too sophisticated. When we work on the back side, we are going to use Excel. I'll talk about that before you get started on the back. So don't begin the economic service life stuff yet. But on the cost effectiveness analysis, what we want to do is find a ratio that tells us which one is going to prevent the most poachers per dollar spent. So go through questions A through D, and I think it will help us to understand where the money should be spent. All right, let's just review and make sure we're all on the same page with analyzing the results here. So the given data was the name of the NGO, how many personnel they have in the organization, their cost per person per year, and the total cost. When you work on a homework problem or if you work on an exam problem, it could be that there's more than one thing that contributes to cost. Like in other problems, it might say, here's their rent costs, here are their labor costs, here's the insurance costs. So what you do is you add everything up, all of the things that they need to do their operations. And so the column would still be total cost that you use for the C in this ratio, but there may be multiple things that contribute to the total costs. Their measure of effectiveness is poachers arrested per year. So when we calculate the cost effectiveness ratio, you'll notice in this case, the units do kind of make sense because the cost was in terms of per year and the effectiveness was per year. So this CER, when we calculate it, what it works out to is how many dollars are being spent for each poacher that's arrested. And it's pretty clear that Habitat XP is the best because you only spend about $2,154 to arrest a poacher when you invest through Habitat XP, but Gorilla Watch, you're spending $36,000 for each poacher that's arrested. Now, of course, numbers can always be abused, you know? Like, it might be that Habitat XP is just arresting people who aren't actually poachers, you know? So you need to sometimes ask yourself, you know, if the incentives are to give out money to the people who arrest the most, are they like legitimate poachers? And it could be that there are other extenuating circumstances that have to be considered. You know, in the case of Gorilla Watch, maybe they're working in a more remote area, protecting a more threatened population of gorillas, and there just aren't as many poachers out there, but the ones that they arrest are really high-level, dangerous poachers. So I'm not saying that this is the only thing that matters. There can be other factors that have to be considered. But if all other things are being equal, like if one poacher is the same as the next, and they're all working in the same region, and there aren't other extenuating circumstances, then you can see the organization that's most effective is Habitat XP. If you've got $5 million, then which one should you select? So maybe most of you weren't watching. There's a sort tool that's pretty handy. Let me delete all this and show you the sort tool. So you just copy the whole thing, Control C to copy, Control V to paste, and so it's in its order right now. And what I want to do is sort, have the most efficient at the top, the least efficient at the bottom, and so up here in the ribbon, there's this sort and filter button, and so we want to have the smallest to largest. And when I click that, you'll notice that it sorts them. Habitat XP at the top, Gorilla Watch at the bottom, and it's gradually in order from there. And so then my column here, which is the cumulative spent, then that's going to be related to, for the first organization, it's just their budget for that year. For the next organization, it's the cumulative amount spent in the row above it plus the amount for this row. So if you're funding these two organizations, Habitat XP and Helping Hands, then it would be $776,000. And then I can drag that all the way down. And what you'll notice is that I can only fully fund through organizations C, A, and E. And then if I can't partially fund, then EcoPlanet and Gorilla Watch don't get any budget from us. Okay, does that make sense to everybody so far? And then the last thing about if these past trends continue, how many poachers are arrested. So I guess it should say arrested based on our support of $5 million. And so it would be the sum of these three organizations' effectiveness. Now here's another kind of nice tool about Excel is when you highlight cells, down here at the bottom it gives you some statistics, average, count, and you'll notice sum. So the sum it says is 495, or I can just put that into a calculation, and that's what I did here, is I just said the sum of those three effectiveness. Any questions on this? Okay, so you've got a homework assignment problem that's very closely related to this, and I think you'll find it pretty easy now that we've been through the in-class exercise together. All right, well, let's move on to talking about replacement decisions. So remember, the whole theme of the course is decision making, and sometimes it's choosing from among alternatives when you're buying something new. But a really important decision that all organizations have to make is how long to keep things when they buy them. You know, how often to replace a vehicle, how often to replace computer equipment or surveying equipment or manufacturing equipment. So when do you replace something? The criteria that are outlined by the book is, number one, is when the performance of something is reduced. So if that means that you're having higher operating costs, decreased safety, lost sales, diminished quality. So your vehicle, think about when to replace a car, when you're starting to miss class or when you're missing work because it's breaking down and it's unreliable. Or you're worried about the safety. Replace your car if it's constantly veering into the other lane. I had a truck with a really loose steering column, and I did everything I could to tighten it up, but man, driving that thing down a windy road was pretty dangerous because like the steering wheel was just loose. I eventually got rid of it. I hope whoever I sold it to figured that out. Another thing, higher operating costs. Now, a lot of people, maybe you've heard this phrase before, like people saying, let's say you've got a car and you got to get the transmission replaced. And you find out, the new transmission is going to be $1,600. And so then you look up the Kelley Blue Book of the car, and it's only worth $1,500. And a lot of people will say, well, I'm not going to do repairs that are $1,600 because that's more than it's even worth. But that is really a false criteria, because the decision isn't you should do the repairs if the repairs cost less than the value of the car. The decision is, should you do the repairs because are the repairs cheaper than your other alternative for transportation? And in a lot of cases, the repairs are cheaper than buying a new car. So I'm still driving around a car. My vehicle, I think, is 18 years old at this point, so I drive a pretty old car because I'm a cheapskate and because I follow this. It's still getting me here on time. The safety is okay. I'm not experiencing any diminished quality. I mean, it keeps me warm and it keeps me dry, and I get here in one piece. So far, my reliability is acceptable. But there are situations where manufacturing equipment, it starts breaking down when it's been used a lot and it has to be replaced. So that's one reason to replace equipment. Another is when the requirements have changed or evolved. Now the picture here is showing a steel mill, and there are some high-grade steels that have to be smelted at really high temperatures that a lot of steel equipment apparently can't meet that same standard. So it may be that the market standards have evolved, or the goal that has to be achieved is more sophisticated than your existing equipment is able to achieve. And so then you have to replace the equipment to meet the new standards. A third reason for replacing equipment is just when it's not necessarily that the requirements have changed, and it's not that the equipment is any slower than it was before, but it's just obsolete for other reasons. And here's a picture of an Apple IIe computer. And this is what I learned how to use computers when I was in like middle school. We had these and we did programming on them. Had floppy disks, no hard drive. The monitor was just two colors, green and black. And this is what we did our programming on. And if you fired this up, it probably still works. I mean, you could probably type a paper on it or do some basic programming on it. But it makes you less competitive if you're using this old equipment compared to a modern word processor that automatically does spell checking, and you can kind of see what you get in terms of like font changes and italicize, underline, bold. The old word processors didn't have graphic user interfaces. And so it may be that it still is able to do the same kind of work, but it makes you less competitive compared to newer technologies. So it should be replaced because it's obsolete. So these are 3 reasons. And here is a curve that is related to kind of the first one, when we think about higher operating costs that arise from having to maintain things over time. So let's look at what's going on. Remember, one of the things I like to do in quizzes and exams is ask you to describe a figure. And this is one where I think there's a lot of important stuff going on in the figure, and so you should be in a position where you're able to describe it. So on the horizontal axis is time, and as we move to the right, that means a greater number of years. The vertical axis is the annual worth of costs. And so what that means is on an annual basis, how much did it cost to keep the equipment for a certain number of years? So let's say that this represents a car, just for sake of description. And if we only keep a car for 2 years before we get rid of it, let's look at where our costs are. The AOC means annual operating costs. So if we sell a car after just 2 years, our operating costs are low because we're not putting a lot of money into repairs. But this capital recovery curve is very high if you only keep an item for a short period of time. Does anybody remember what capital recovery means? This is a phrase that we've talked about before. Salvage value is a part of it, but there's another part as well. Not quite, no. Let me sketch on the whiteboard what capital recovery is. Okay, so you buy a piece of equipment, that's an outflow in year 0, and then you keep the equipment for a certain number of years, and then you have some salvage value or market value. And so this is the initial purchase. In year 0, and it's an outflow, so it's going to be some present value. And then we've got some future value, and what that is the salvage or market value. We call it salvage value if the item's kind of just being scrapped. If it still has residual life and it's going to be used by someone else and not just melted down, then we'd maybe use the word market value. Okay, so we've got these 2 things, and what capital recovery is convert it to an annual series that takes both into account. So what you're trying to do is you're trying to find out what is the equivalent annual amount that takes all of that into consideration, including the last year. So this is capital recovery. And when you calculate it, it tells you how much revenue you need to cover the cost of the equipment, accounting for the initial purchase price and the market value when you get rid of it. Okay, so let's go back to this figure. If you keep things for just a little bit of time, capital recovery is high because you're putting all of that purchase price into a few number of years. But then if you keep it for a long time, like my 18-year-old car, the cost of ownership per year is really low because I'm spreading it out over a lot of years. If we look at this vertical axis, remember it's saying the annual worth of the costs. So the purchase price and the salvage value and then a lot of years, how many years are you going to spread those costs over? So if you keep it for a lot of years, capital recovery is low, but then the operating costs are creeping up because you have to put in new brakes, you have to put in maybe a new clutch, a new transmission, and so on. So this blue line then is the sum of the 2. And if we want to minimize costs, what you're trying to do is find the point where this curve is the lowest. So the best operating point is called economic service life. And I'll ask this on an exam, almost certainly. I'll ask you to define economic service life. And the answer is, if the question is what is economic service life, the answer is It's the number of years associated with the lowest overall cost. So the cost of ownership is minimized at the economic service life. And people who aren't here today will make up some definition about something else, but it's the number of years associated with the lowest overall costs. And just to emphasize, this is an annual worth basis. Let me ask you a question. What do you think is the most complicated spreadsheet you've done this semester so far? Any opinion? External rate of return? Yeah, that one's pretty complicated. Maybe a close second would be the incremental annual worth analysis, because on that one you had to do some goal seek. Okay, today's is just a little bit more complicated than either one of those. I mean, it's not like career ending, you're never going to get it. But if you pay attention and follow along, it'll be fine. But I acknowledge that this is a little bit abstract. So your focus for the next 20 minutes will pay big rewards. If you can follow with me for the next 20 minutes, then you'll be in good shape. So what we're going to do is we're going to try and find out how many years is it to minimize those costs. And when we do a replacement study, there's a little bit of terminology that you need to be acquainted with when we're comparing alternatives. And so the defender is the thing that you already own. And if you're trying to figure out whether or not to replace that existing equipment, the new item that's being considered is called the challenger. And it's the best of the options that you've got to replace it with. We already talked about what market value is, and you already know economic service life is the number of years with the lowest annual worth of costs. And the first cost of the defender, what you need to do, if you're comparing keeping something with replacing it, then the cost you assume for the existing equipment is how much it's worth now. And the reason for that is a little bit complicated. Remember, everything has an opportunity cost. Every decision has an opportunity cost. And if you keep your existing equipment, that means you can't sell it. So what this is saying is, if you're comparing option A and option B, and option A is something you already own, you paid for it a long time ago. But from the perspective of right now, if you keep that item, that means you can't sell it. So the cost that you should assume when you're comparing existing equipment to new equipment is the current market value. That's the correct way to consider what the cost of keeping the existing equipment is. Now, the challenger first cost is just how much you'd have to pay to purchase it and put it into service. Now, there's also a term identified by the book, the idea of sunk cost. And this is another trap that sometimes people get into with their vehicles. I already told you about sometimes people aren't willing to do repairs if the cost of the repair is worth more than the value of the vehicle, and that's a fallacy. Another logical fallacy is thinking that just because you previously spent a lot of money on putting new tires and changing the brakes and maybe doing a tune-up of some sort, that your car has a higher market value than an exact duplicate car that didn't have those maintenance items done recently. Like, you kind of get emotionally attached to the money that you've spent in the past. And that's called a sunk cost, your previous expenditures. And for purposes of the economic analysis, you just have to ignore all the money you've spent before and just look at from now forward. And that's painful to do, but the fact is that we don't include sunk costs in studies of whether to keep existing equipment or to purchase new equipment. Okay, so let's do this first economic service life. As I mentioned, there's a template file on MU Online. Now, the equipment that we are looking at, if you are going to initially purchase it, it's $20,000. And what we're trying to do is figure out how long to own it. In this case, the analysis is, should we own it for 1 year? Should we own it for 2 years? Basically, how long should we keep it before we sell it? Our criteria is we want to minimize costs. So we want to find the lowest annual worth of total costs. And the costs include not only the capital recovery, but also the operating costs. So you look in the data here. What I'm telling you is that if you sell it after the first year, then you'll be able to get $10,000 for it. If you sell it at the end of the second year, you'll get $8,000, and so on and so forth. So that's what we're talking about with this MV column. The operating costs follow that trend that we'd expect, that the longer you keep it, the higher the operating costs go. But what we want to do is find the economic service life. All right. So here is the template file. Here's what it looks like. Did everybody able to find that on MU Online? All right. So I've given you the formulas here, but beneath the table. Column A is given, column B and C, they're given. Now, column D says use the NPV function on the costs for whatever row you're on. Okay, so for the first row, it's just going to be the NPV of 5,000. So you'll put that inside the function. In the second row, it'll be the NPV, and you're going to select 5,000 and 6,500. So let me bring up that template file, and we can go through it together. All right, so I've got that template file up. By the way, I'll mention that the interest rate here is 10%. So the reason for that interest rate is time value of money has to be accounted for. All these amounts in the future aren't worth the same as if they had been spent in the present. So these market values, for instance, are going to have to be discounted. The operating costs are going to have to be discounted, and so on. Okay, so present value of cumulative operating costs to date. So I'm just going to do the NPV function equals NPV at 10% interest rate. And for the first one, it's just that 5,000. So what that's doing is it's taking the 5,000 from year 1 to year 0. So this would be the same if I did the PV function, I'd get the same result. But NPV is going to be useful for these other ones. I can't drag the formula down. I have to type it in again. NPV, and the rate will be 10%. And this time, the values are the 5,000 and the 6,500. Because what I'm doing is I'm saying if I keep it for 2 years, then I will have experienced the operating costs from the first year and the operating costs from the second year. So each row is talking about what if you keep it that number of years. So the third row, NPV at 10% interest and 3 years worth of operating costs, and so on. Okay, is everybody with me so far and filled out column D? So let's take another look at what that title is. It's the present worth of the cumulative operating costs to date. So just as an illustration, if we keep it for 3 years, then what we're saying is we want to take all of those operating costs back to the present. So if we keep it for 3 years, then we've got operating costs of $5,000 in year 1. Year 2 is $6,500. And year 3 is $8,000. And what we did was we took those amounts and found the present value for 3 years of ownership is $15,928. $15,928. And so each row is saying if you keep it for this number, this many years, here's the present value of the operating costs. Okay, now the next column, column E, we're taking this present value and we're spreading it back out over an annual series so that it's equal amounts. So look at the whiteboard. Instead of having a different amount each year, we want to find out, take this present amount and how much would it be if every year it's the same cost to cover the annual operating expenses. Okay, so we're converting it back into an annual amount. Okay, so you'll notice it says that we're doing the payment function, PMT. So equals PMT, the rate 10%, the N is going to be whatever row we're on, and the present value is going to be we have to use that opposite sign of the present value. Okay. So for the first one, it's 5,000, and that makes sense because it was 5,000 to begin with. If we're just keeping it for 1 year, then the annual amount of the operating cost is 5,000. Now the rest of them, it's not going to be exactly the same as the original given amount. I might need to anchor the interest rate. Okay. So what this is telling us is the annual equivalent. Like if we had some sort of a plan that spread out the annual operating costs. You know, the electric company does something similar to that. The electric company noticed that, you know, people's electric use in the summer is a lot higher, and some people have trouble paying their bills in the summer because electricity is more expensive. And so you can sign up through most electric companies like kind of a program that takes an annual average of your electric use and then just kind of evens out the payments so there isn't as much wide variation. And that's the same kind of idea of what we're doing here is instead of having a different annual operating cost every year, you know, if we keep it for 5 years, what that means is if we keep it for 5 years, then our annual operating costs will be $79.61 each year instead of having $5,000 in year 1, $6,500 in year 2, and so on. Because it can be hard for a business to have a gradually increasing operating cost. It's a lot easier to be paying the same amounts every period. And so that's what we have. If we own it for this many years, here's what the annual operating costs will be. Now remember, what are the two things that make the total cost? It's the capital recovery and the annual operating cost. So we have to do the capital recovery now. You'll notice here it's saying to do the payment function, but we're going to put two things into that payment function. We're going to put in the initial purchase price and the market value in the same function at the same time. Okay, so we're going to do PMT. We'll have our 10% interest rate. I'll anchor that reference so I can drag it down later. Okay, N is whatever row we're in, the year. Okay, the present value is going to be the first cost, and we need to anchor that because it's always going to be looking at that. And then the market value is going to be whatever row. It's the market value associated with the number of years we're using for this row. Now, I always get thrown off about whether I I think that we don't have to add any external number switches in here because we had a minus for the first cost, but let's see if the results make sense, and we might have to throw a negative sign in there, but I think we might not need to as written. Okay, it actually should be the opposite of that because we want it to be an outflow. So I'm going to just put it before the payment function. So what it's saying is if we keep it for just 1 year, let's put some actual numbers with this just to make sure that it's making sense to us. If we just keep it for 1 year and we buy it for $20,000, P equals 20,000. $20,000 purchase price, salvage value for 1 year of ownership, $10,000. Then what is the equivalent 1 year cost? And so what we're going to be doing is we're going to be finding out how much is the annual equivalent of that. So we're essentially taking the 20,000 forward 1 year and then subtracting it by the 10,000. So the capital recovery, then we can drag that formula down, and for however many years we're owning it, you'll notice that the capital recovery costs decrease, and that's the trend that we would expect because you're spreading out the cost of ownership over a greater number of years. So for instance, $20,000 spread out over 5 years, and then the market value has gone down to 0 at that point. It has no salvage value at the end. So it's essentially we're find A given P for 5 years and 10% interest. And so let's just double check to make sure that that's working out. So we want to find A given P. So find A given P for I equals 10% and N equals 5. And then we're going to have $20,000, so P is 20,000. Anybody have the textbook today? Can you find the 10% interest rate table? Let's just double check this by using the interest rate table and make sure that our capital recovery is working the way we think it ought to. For the 10% table, the find A given P. 5 years, yep. 26380. Thank you. So 0.26380. All right, so if we multiply that by 20,000, so you said 0.26380 times 20,000, 5276. Perfect. All right. So if we keep it for 4 years, there is some market value at the end. It's less years, but there is some market value. So capital recovery for each of the years. Now our total cost, here it's saying it's column E plus column F. So equals E and F. Drag that down through. How many years should we own this equipment? 3 years. Yep. We should own it for 3 years and then sell it at the end of the 3rd year. And that is the action that will minimize our costs. Hopefully, we'll be able to, at the end of those 3 years, we know to sell it in 3 years. Sometimes you need to revisit these each year just to make sure that conditions haven't changed. What we're doing is we're saying right now we know what the market value will be, in year 3, in year 4. This column B is probably just an estimate that we're making. And so the way these are usually done is you would make this, you'd do the analysis this year, and then next year you'd check to make sure it's still true. You'd go and you'd look, like on the secondary market, how much are people willing to spend for 1-year-old equipment, for 2-year-old equipment, and so on. So you'd maybe make a revised spreadsheet and make sure that the operating cost projections haven't changed. And so annually revisit to make sure that things are following the trends that were projected. So now you know how to do economic service to life analysis. It's honestly not that bad. I think the thing that people struggle with is using the NPV function. And so in bold here it says of the range so far. So it's not of the entire range, it's just of the range so far. So remember how we applied that. It's for whatever row you're on, the NPV only includes the operating cost for that many years to date. Yeah? Any questions? Be sure and save this spreadsheet file so that you can use it as you're working through the homework assignment. Let's take one last look at these announcements before I turn you loose. We've got a lot coming onto our plate in the near future. Tomorrow, you've got homework 10 due by 5 o'clock. Thursday, so a week from today, you'll be just about finished with the exam at this point. So remember that we've got a homework assignment due that day, and you need to bring your computer and start thinking about what's going to go on your formula sheet. And maybe more than making it a formula sheet, making it like an analysis procedure sheet. And like, what is the decision criteria? Because remember, it's not just about getting the right numbers, but it's about deciding which alternative is best and why. So being able to know, like, what are the rules for accepting one thing versus another according to each of the methods that you've learned. All right, well, that's it for today. I'll see you on Tuesday.